Hi, I'm Ryan of MidNite Solar. Today I want to show you how to use the classic string sizing tool. The string sizing tool can be found on our website at www.midnitesolar.com. It's about partway down the home page. We'll show you where that is in a minute. Before you go there, we do need to know what solar panel you plan on using. In my case, I have Solar World 235s, so I've gone ahead and written down the specs that are found on the back of the panel. They can also be found from the data sheet on the manufacturer's website. But I do have those specs on my paper here. I'm ready, so let's get going. Let's head on over to midnitesolar.com, as you can see here, and I'll go back to the top of the page so you can see. We're going to scroll down the page part way. We're going to classic string sizing tool. Okay, here is our string sizing tool. The first thing we have to decide, are we talking Celsius or Fahrenheit in temperature? I use Fahrenheit here in Maine. I'm going to go ahead and click Fahrenheit. Okay, now we need to enter our information. In our case, the panels are 235 watts. The VOC is 37.5. The VMP is 30.3. Now I'll explain VOC, as it says on the screen, is volts open circuit, referred to as open circuit voltage of your solar panel. VMP is the maximum power point voltage of the panel. Also, ISC, which is coming up, is short circuit current, and IMP is maximum power point current. Okay, moving on, the ISC for these panels is 8.19. The IMP for these panels is 7.77. Now, we have a temperature coefficient, VOC temperature coefficient, which is referred to in a negative percentage, and we also have a VMP temperature coefficient, which is referred to in a negative percentage. In this case, on the Solar World panels, it's negative 0.33% and negative 0.45% respectively. I'm going to go ahead, that's already standard by default. That is a default value. I don't have to change anything. I'm going to go down to the coldest ambient temperature I experience. In my case, the coldest ever is about 35 degrees below Fahrenheit, negative 35. And the hottest we're probably ever going to see is about 95. I'm going to pick my battery voltage. In this case, it's 48 volts. And I'm going to say I want to do 20 panels. Let's start there. I'm going to do 5 in series and 4 strings of 5. What that means is that I'm going to have 5 panels wired positive to negative, positive to negative, positive to negative to make 5 in a series string. And then I'm going to take 4 of those strings and bring them into a combiner box and combine them down to my charge controller. I'll click Submit Parameters, and here we go. As we can see, right off the bat, the first thing you notice, your eyes notice, is there's a lot of red here. Excessive, too high, 1.3, 1.5. So we'll get to that in a minute. I want to start at the top and run down through here. The rated PV array power for this is 4,700 watts. The anticipated power at 95 degrees, based back on that negative 0.45% VMP temperature coefficient, will become 4489 or 4,489 watts. The rated PV current is going to be about 31 amps. The rated battery charging current at 57.6 volts is 81 amps. The maximum power point voltage is 151.5. The rated open circuit voltage is 187.5. The corrected maximum power is, the corrected voltage at negative 35 is 226 volts. The maximum operating voltage for the 3 versions of the Classic plus the KS, as you see there. Maximum non-operational hypervoc voltage for this battery bank voltage. Now, hypervoc is a non-operational safety zone. You'll notice you can click on the link there. It will take you to a write-up about hypervoc. What that does is, in my case here, where I get really cold in the winter, it allows me to put a little bit more panel in series, and on those rare mornings it does get that cold, we'll go up into the hypervoc region. The Classic will not turn on. It'll wait for the panels to warm up enough for that voltage to drop back down. Next line, maximum number of modules in series. This is without using hypervoc. You see we can put 3 in series and still be functional. 4 in series and still be functional, 5 in series on this one. Again, we selected down here that we wanted 5 in series, but all this is telling us is, hey, these are as many as you can do in series on this model Classic. So on a Classic 150, we can only do 3 solar worlds if we do not want to go into HyperVOC, and 4 if we may want to use HyperVOC. Maximum allowable output current per Classic, 76 amps in this configuration, 65 on a 200, 55 on a 250, and 50 amps on a Classic KS. Maximum allowable wattage per Classic based on this configuration. This 150 in this configuration is good for 4,438 watts. This one is 3,796. This one is 3,212. And on a KS, for instance, is 2,900 watts. This array is 4,700 watts all the way across. The maximum VOC for a Classic 150, as you see here, is too high. As you see on the light, it's marginal. It will use HyperVOC. You will notice it goes into HyperVOC at 41 degrees Fahrenheit. That's not going to work for me here in Maine. In Maine, we spend a lot of time below 41 degrees Fahrenheit. I would say we spend a lot of time down around 0 Fahrenheit. So I would not pick a 200 for this application. I'll go over here and I'll say, oh, it's okay on a 250. HyperVOC is negative 104.8 degrees Fahrenheit, so we're good there. But you'll notice that we're excessive, and it shows that we need 1.5 Classic 250s. So what that's telling me is this array is too big for a Classic 250. It's okay size-wise for Classic 150, but it's too high a voltage. So knowing this now, I have 2 choices. I can say, do I want to go reconfigure the array for a Classic 150, or do I want to install 2 Classic 250s? I'm going to try reconfiguring the array. I know I want 20 panels. Let me back down to 3 panels in series, and you know, it doesn't add out evenly, but let's say 7. I'm going to try 7. That's 21 panels. We'll submit the parameters. Now you see here, we're perfectly fine. We can use a Classic 150. We're all, you know, we're good there. We're a little bit over on the wattage, but as you see, MidNite Solar considers 1.1 or even 1.2 to be acceptable. The reason we consider that is most solar arrays run at about 80% of the nameplate at best. So if you've got 1,000 watts of PV and you put it out in the real world, you're going to get about 800 watts out of it under normal conditions. The rating the solar panel manufacturer uses is in perfect test conditions, not out in the real world. So that pretty well sums up the string sizing tool. I do want to point out, like I say, the 1.6. Again, if we wanted to go back to that 5 and 4, we go back to 5 in series because we know we want to use a 250. So now we'll do 2 strings. This would be half of the 20 panels that we originally wanted. Now you can see we're perfectly fine on a 250. So if we were going to do that with 250s, we'd need to use 2 Classic 250s and put 10 panels on each Classic. That sums up our string sizing tool. Any questions or concerns, please feel free to contact us. Text support at MidNite Solar. Give us a shout, email, whatever you will. Check out our forum. Until next time, I'm Ryan of MidNite Solar.